Hello, I'm Daniel Higuereta, and my lab partner is Marlon Hernandez, and this is my video demonstration for EE 329A4 assignment for this class. For the first part of this class, or for this lab assignment, we were messing around with the clock configurations that the Nucleo or the STM32 has to offer to generate waveforms. And then the latter half of the lab, or the last part, was implementing interrupts and timers separate from our usual delays that we had in the past to play a little user interaction game, the reaction of the user pressing a button when an LED turns on. And here's the code for that. First, starting with so I had the LCD from a past lab, so that was just pulled into this one, as well as a delay. The new files are the timer, and then the main.c was modified for this lab itself. In the timer, it's really just initializing a lot of pins, so pin setup, and then provided code such as the TIM2, the handler, and the MCO clock. And then here's the more specifics of configurations of those pins. I use GPIOE pins 2 and 3 specifically for the waveforms, so parts A, B, and C. And then part D, I use just GPIOC, since those are the onboard LED and buttons. And the main.c, it's just a lot of initializations. So initializing the clock, initializing pins, and the LCD. This one's mainly for part D. And then over here, we go into our infinite while loop where we just initialize everything, counters, variables. And the first thing we do is we check if the user button has been pressed. And this is what starts the game, because then we go into our little case statement over here, where once the user button has been detected as pressed, we turn on the LED and start the react timer, and it counts. Then we move on to our next state, which records the reaction time of the board, and then the LED turns on. So we have a random number generator, and that's in the case 0, which delays a certain random amount of time for an LED to pop up. And once that LED pops up and the user presses a button, the user button, it'll then take that reaction time, as right here it's recording the current reaction time, doing math to convert it in terms of seconds and milliseconds. And once it detects you've pressed the button within a reasonable amount of time, it'll do this conversion and print it to the LCD. And then you reset the game by pressing the reset button, and it goes back all the way to the top, initializing everything all over again. Here is the LCD in play. First, this is how I press the debug for the code to just be debugged and upload to the Nucleo. And here it says it has downloaded successfully. Then I press this play button up here, and now the game is ready to play. So here we have the initial display, and once I click this user button, you'll see an LED eventually pop up right there. And I press the user button, and it took me about 4.66 seconds of a reaction time between when the LED turned on and when I pressed the button. Now all I have to do to reset the game is literally press reset, and it'll wait for me to press the user button once again. The LED button the LED is on, and I press the user button again. It took me 5 seconds. And that was under a second.